Okay, welcome back. Today I'm going to graph some step functions with you. Now you've been doing piecewise functions, and this is just a type of piecewise function, and it's called a step function, and you're going to see why in a little bit once we get it graphed. So if you guys could copy down this first example and maybe keep the heading on there. And I've got plenty of graph paper, you guys know that, it's on my desk. So just grab a piece of graph paper if you want. Okay, so once you have that all copied, and sometimes you might need to pause in order to get it copied because I'm going to keep moving. You can see that this one has, now I call them, because it is called a piecewise function, I call them pieces. So it's got 3 pieces that we're going to graph. I'm going to do the little T-chart method as you've been working on for each one. I'm just going to set them up right here. So we're going to have our X. And then what I'm going to put for the Y column is I'm just going to go ahead and put in the Y value. So it's just going to be -2. Actually, there's no X on it. And so this will be X, and this will be paired with 1. And then X paired with 3. Because that's what this is saying. The first function is always -2 if X is less than -3. So here's where these pieces come in. X is less than -3. So I'm going to include the -3 in my table. And it says less than, so I'm going to go smaller with a couple more numbers. And then another thing, I know Miss Wade or Miss Thomas talked to you guys about this. This is just a less than, doesn't have the equal to. So this boundary is going to be an open circle. And I kind of put those right in my table. Okay, I'm going to keep going. So the next one is going to be in between -3 and 2. So I'm just going to do -3, maybe 0, and 2. And at all of those X values, Y is going to equal 1. And on this one, since we have the equal to on the -3 side, this one's going to be closed. And then on the 2, it's going to be open. So that's more like a line segment. And then finally, our last piece is greater than or equal to -2. So I'm going to include the -2 in there. And I'll just do, -1 and 0. And that's all going to happen when Y equals 3. And if I look at my end with the -2, that point is going to be closed because it's equal to -2. All right, so now we're going to come over. You guys should make a little graph. Mine is about, I think, 12 by 12. And then I'm going to start plotting. Oops, I forgot on this one. I do have to plug in my -2. Because at -3, -4, and -5, that's when X equals those. My Y is -2. So now I think I've got my tables complete. So now we can graph. So at -3, -2, I have an open circle. And then the rest of the points are just normal. So -4, -2, that's just a point. And then -5, -2. And that's just whenever X is less than -3. So that's going to go this way. It's going to be like a ray. Then I'll go to the second piece. So negative 3, 1, that's going to be closed on that end. So that's equal to negative 3, 0, 1, and then 2, 1. Oops, back up. That last one, remember I said earlier, has to be open at 2, 1. So I'm going to erase that closed and write that in as an open. And then, like I said, this is like a line segment. And then the last piece starts at negative 2, 3, and that's closed. Negative 1, 3, and 0, 3. So this one is just going to keep going, like I could keep going greater than negative 2. That's going to go out this way. And what does that look like? It looks like a series of steps going up. 1, 2, 3. Hence the step function. Now I am going to talk about domain and range real quickly. And I have certain notation that I use: D for domain, R for range. So from left to right, I'm not going to have any breaks because these two align with one another. One open, one closed. And then these kind of overlap, and that one keeps going to the right. So this first one for the domain is going to be all real numbers. Or if you guys are learning the infinities. And then the range, well, the only values for y that we're graphing are at negative 2, 1, and 3. So I'm going to say y equals negative 2, comma, y equals 1, or y equals 3. And that would make my range. Okay, let's keep going. Move this up. We've got another function, so take a second and copy that down. I'm going to do the same thing. So I'm going to set up my 3 little tables. So this will be x0, x and 2, and x and 1. So the first piece is going to be between 0 and 1. Well, I'm just going to use 0 and 1 because it's a very small range. And it's not equal to, so both of these are going to be open circles. And then the y value will be 0. Second one goes between 1 and 3, so I'll do 1, 2, 3. And those are also going to be open. There is no equal to anywhere on this problem. And my y's are going to be 2. And then the last one is greater than 3, so 3, 4, 5. And on the 3, it's going to be open, and that will be paired with 1. All right, so let's make a sketch of this one, see what it looks like. So I'm going to go back to the first table. So 0, 0, it's open. And then 1, 0. So that's just like a little step right there. Just kind of connect those, all the points in between those. And the second piece, so 1, 2, open. Now 2, 2 is just going to be a point in between. That's just going to be a regular point. And then 3, 2 is going to be another open. So it's another segment. It just kind of crosses over there at the 2, 2. And then finally, the last piece is 3, 1. That's going to be open. 4, 1. That's just a regular point that's in between, and then 5, 1. And that's going to be just a regular point, because this says x is greater than 3. So it's going to be all numbers that go greater than 3. So that's going to be an arrow. This one's kind of a strange one. It's got steps, but they're not really looking like regular steps. You kind of go up a step and then back down a step. Okay, thanks for coming.